All right. Hello and welcome to the next episode of 3D and 30. Today we're going to be talking about realizing your innovation without compromise. 3D and 30, as you may know, is Velo3D's LinkedIn Live and YouTube Live channel. We host this about every 2 weeks, but keep in mind we are going through trade show season and holiday season, so we're adjusting the schedule. Make sure that you follow Velo3D on LinkedIn to get the latest show schedule and what we'll be talking about next. So today we're going to be looking at the question, basically, is metal AM right for you? And many companies right now are using Velo3D's metal additive manufacturing solution for their production needs, leveraging an unparalleled level of design freedom to realize their parts, improve performance, and streamline supply chains. But you may be thinking, well, what about my company? What about my application? How do I figure out if this technology fits and creates real-world business value for me? And that's what we're going to be talking about. We're going to dive into that in our 3D and 30 today. And in this session, we're going to be looking at the checkpoints or the gates most commonly used to evaluate metal AM technologies. And we're going to be leveraging the experience of our US distributor for Velo3D solutions, GoEngineer. So questions like, can you print it? What's the cost structure? Are the right materials available? And can you scale? And helping me today navigate this will be GoEngineer's Tyler Reid and GoEngineer's Josh Brown. Welcome to the show, gentlemen. How are you doing today?
Good, thanks,
Doing
Mike.
well, Mike.
Awesome. So let's get a little bit of introduction from your side. Tyler, tell us about yourself and a little bit about your background.
Sure. So my name's Tyler Reid, and like you said, I'm at GoEngineer. I'm the technical director for the digital manufacturing group at GoEngineer. The digital manufacturing group is centered on modern manufacturing tools, including additive manufacturing. And I've been in the additive space now for about 10 years in that capacity.
Awesome. Josh, a little bit of background from you, please.
Yeah, absolutely. Josh Brown, I've been with GoEngineer about a year now. I'm the director of metal additive manufacturing. They brought me on to help develop the market for the Velo3D system. And it's been a great time so far, and partnering with Velo has been awesome.
And for those who are new to GoEngineer, could you give us a little bit of background about what GoEngineer does?
Absolutely. So GoEngineer, we are a reseller of both software and hardware. We're the number one reseller in the United States for SolidWorks. We were also the number one reseller in the US for Stratasys polymer 3D printers. And now adding Velo3D to our portfolio of systems really gives us a really broad band of products that we can offer our customers.
And how long has this relationship with Velo3D been in place?
We've been involved in partnering with Velo for about a year now, and really starting to make some traction and get some good interest built up. So it's been, like I said, it's been awesome.
Can you comment a little bit about what sparked this partnership? What made Velo look like a good fit for you as a distributor?
Yeah, I mean, I've been in additive manufacturing, Mike, for about 10 years now. And so many of these metal additive systems that we've seen, or I've seen personally, have kind of been Me Too systems, where a lot of the machines do the same thing. And so we really wanted to partner with a company and a machine that was different, that was really leading the charge in terms of production technology. And when we found out about Velo3D, its capabilities, and really what the purpose of Velo3D is as a manufacturing technology company, it really fit kind of the scope and the vision of where we wanted to go with metal 3D printing at GoEngineer.
Very cool. So Tyler, coming back to you, you're on the front lines. You're talking to customers. You're getting an idea of whether this technology fits. And so maybe you could paint us a picture just at a high level right now of what that process looks like.
Sure. So at a high level, people around us in the country have parts to print or to create, to manufacture. And they have a lot of options available to them. And especially over the past 5 or 10 years, people have been searching for new ways of creating parts that reduce lead time and improve the capabilities of the parts, especially as we see new levels of software empowered optimization come into play. There's a dynamic where we have designs that are high performing, but no real way to produce them. And so as people come to us and search for solutions, be it CNC machining or other types of manufacturing, additive has always been on the top of their list of investigative routes. And so that's kind of what it looks like right now in terms of searching for ways of creating parts.
Nice. And, Josh, maybe you could give us a little bit of color here. And what have you seen that works that helps these customers figure out quickly whether it's a good technology for them?
Yeah, I mean, actually, Mike, we have a checklist that we like to go through, a very basic checklist with our customers to even see if this is a good solution. And it starts as basic as answering the first question of, do you make metal parts? At GoEngineer, we have a wide range of customers that manufacture and do all kinds of things. And so just answering that simple, basic question, do you make metal parts, usually leads us to the next question. If that's a yes, how do you currently make those parts? And if it's currently being done through sheet metal or stampings, that might not be a great fit. And so that helps kind of drive the third question of what's the material and what is the size of the part. Because we know we do have restrictions in terms of what materials and size currently can fit on a system. And so those are kind of the three first, gates, I would say, in driving a customer to see if we move on to that next step of actually evaluating their parts.
Yeah, it'd be nice if there were like a horoscope for this, or just some simple, hey, if you're born in this month and this time, look for somebody born in this month and this time. But it seems like there's more layers to it. So let's kind of navigate the path to yes here in a little bit more detail and look at those gates. So Tyler, let's say Josh has qualified them, they make metal parts. It sounds like there might be a fit here. What are you going to be looking at in the actual application to see if it's the right one?
So that process is something that we really try to make happen as quickly as possible. So usually we're looking for no's at first. We are trying to disqualify a lot of the interest coming in to us and trying to understand, like, if the answer is no, does it need to be no? And oftentimes what's happening is people are making metal parts and they have a process that works well, but they have a pain point. And if we can identify a pain point, then we can kind of work around that. And within this process, what we find is that if you're coming to additive with a design that you're currently machining or you're currently casting or forging or something like that, and you want to go directly into printing, then usually the answer is no. There's this concept of design for additive or just design for manufacturing more broadly. And so part of that discussion in the journey to yes is asking them, what's actually functional about this part? What's the purpose of this part? What's required of this part? And can we achieve that, hopefully to a greater degree, while designing for additive to make it work? So a lot of times the journey to yes is, you have to get past some no's, and that's just part of the process.
Yeah, and you did mention DFAM or DFAM, design for metal or design for additive manufacturing.
Yeah.
And how do you see the principles of that versus for the industry in general, and compare that maybe to what you see with Velo?
Sure. So I would say, in my opinion and in my experience, design for additive is no one set of rules. You really are designing for specific processes and even specific machines. So where you see a difference is how restrictive those rules are. If you're designing for binder jetting versus laser sintering versus DED, all of those rules look differently. And then even within a certain pillar, say laser sintering, which is where Velo is, not all machines and not all hardware and software workflows are the same. And going back to one of the earlier questions about what really drew us to Velo, a big part of that was they're still designed for additive rules, but they're much less restrictive than, I would say, competitive tools. And that allows people to design first for function. And it is unique enough that I would actually encourage people who are looking into designing for additive, like, don't go too far without some expert eyes on your part. Actually start from a point where you have your function, but don't lightweight it, don't do other things without talking with an expert, because you could spend a lot of time doing something that you really don't have to do on a Velo system.
Yeah, I know we've seen a lot of parts, and guys come in and they are used to designing parts for additive, and they've compromised or changed a lot of functionality to it that they really didn't need to do. They're thinking additive is one thing, and in general, I think where you're pointing them to is, design for function first, and then let's see what's going to go on. Don't assume a manufacturing solution. Don't assume compromises in day one. And I mean, we've got, I'd say 9 out of 10 of our case studies are exactly that, where guys came in designing for functionality. Now, at first, it was a struggle because they couldn't find a way to manufacture it. But now that more people are aware of what Velo 3D can do, that's sort of the pathway that we're seeing is pretty effective there.
Yeah, I would say coming to the table with the simplest part that gets the job done at the highest performance level, and then start from there. Because the reality is that it's harder for us to uncover part decisions that don't lead to performance gains. Especially us, Josh and I, in our position, we're not going to tell the designer, or ask the designer, why did you do this? Why did you do this? So we almost have to make an assumption that you're coming at us with the actual part that you want, right? And if you're not, then you may not be able to take as much advantage of the Velo capabilities.
Yeah, and just kind of that knowledge, and maybe coming in as a designer with some characterization of, hey, these are mission critical. I have to have this like this, and some of these other things maybe we could examine and look at. That goes a long way to sort of breaking down those walls and getting quickly to metal parts.
Right. Assume nothing.
So, yeah, go ahead.
I was just going to say it. Assume nothing.
Yeah, I know. Brand new technology. With the new technologies, there's a lot of learning and questioning of original assumptions. So
yeah,
that's probably a very good guiding light from this session. So, maybe Josh or Tyler, when do you call on Velo? How is that relationship working? Are you guys just kind of know everything at this point, or you see that, how comfortable are you with it?
No, I mean, the great thing about Velo is we've been able to learn fairly quickly with the machine and how it works and really what the benefits and capabilities are. We're not by any means the experts, which is where Velo's team comes in and assists us. And so a lot of times me and Tyler will do a lot of the qualification up front and get these parts and get some of these, applications kind of in the pipeline. And then we'll bring in the Velo experts to make sure that we're on the right track, get some input from their team. Or sometimes there's just really complicated parts that come in that we need the Velo expertise. And that may be in a specific industry, like a rocket engine, Mike, that you guys are so well versed at, or other applications. I mean, me and Tyler are just a team of two here at GoEngineer, and the resources you guys have at Velo have been extremely helpful for us, and we'll continue to lean on those guys and gals, moving forward.
And I would say, having the burden of updating the marketing content, it's constantly evolving. We'll make some content for 6 months ago, and now the technology's evolved and changed, and the metals are different, the capabilities are different. The envelope constantly is getting pushed in that direction, which is kind of what you want, I think, in a technology.
Yeah, I do have something to add here, Mike, because I really think that it's important that I share my thoughts around the partnership and the idea that we at GoEngineer have customers that are creating some of the most amazing assemblies and achieving some wondrous accomplishments. And it requires the best tools to do that. And part of what we do is we go out into the industry and we search for those tools, but we are also searching for the organizations and the people behind those tools. And going back to that original question about, what drew us to Velo, that's the other side of it, is the expertise behind the tool and also this partnership, or I would say relationship with your customers, that I would compare it to almost like a concierge service. It's a premium partnership. And I want to use the word hand-holding, but that sort of has a negative connotation to it, because you have very, very capable customers, and your customers teach us as well. But it is sort of like hand-holding in the sense that you guys are side by side, and you are carrying your customers to success, and you place the burden of their success on you, which that gets into, a little bit about your actual tool, but in the sense that you are taking on the burden of their success, which is very unusual in additive.
Yeah, I'd have to say the team is brilliant. It's definitely one of the most brilliant group of people that I've had a chance to work with. They're pretty amazing. But yeah, let me jump back into the checklist real quick. I know we've got a couple more things to jump through, and I do want to say, let's be engineers about this for a little bit. There are geometries that are problematic, and we know aren't going to be a fit, and maybe we can put some of those out on the table. And maybe Tyler, you're the right guy for that.
Geometries that are not a good fit?
Yeah.
Okay. Well, things that are too big or too small. So you have physical limitations, right? With the hardware solution, you have a physical build size. So if you're beyond that, then that's going to make it challenging. And then also too small. If you are printing micro parts, that's going to be a no-go situation as well. But I would also say that Velo is really highly tuned towards very complex parts and very complex applications. So brackets, for example, just a standard part for metal AM for the past 10 years, probably not the right fit for a Velo system. It's a great fit for legacy systems that were designed to handle simpler parts. But the Velo system is the next generation. And we're really looking for parts that represent, very highly functional, high value parts.
You said brackets. I thought you said rockets. I was like,
rockets.
Rockets is kind of a sweet spot. So
yeah, you would have questioned my fitness for my position if that's what had come out of my mouth.
Yeah, no, I'd say we're not going to make a turbocharger for your BMW or for your Honda or whatever, right. But we might make one for the next rocket that goes into orbit. So.
And, I mean, the geometry fits there, but that's a question of throughput and other discussions here.
And so maybe Tyler, Josh, to switch it over to you. What do you see in a part that lights up your it's like, hey, this is going to be a great fit. This is ideal, perfect.
No, you do get those occasional golden opportunities, as we call them, that come in, and the parts are a perfect fit for the Velo system. And a lot of those parts, are fluid flowing parts, they're spinning parts, they're complex, complex geometries, or, parts that really the material cost may be 20% of the overall part cost, Mike, because they're doing so much extra processes in that part. And some of these are complex assemblies where you're printing a part and then you're doing welding and brazing and combining, multiple parts into one. And when we see that, and we know that we can utilize, Velo's capabilities in part consolidation, in utilizing channels where maybe before companies had to design a teardrop shape, right, Mark or Mike, so that you could actually print a channel through the components, where we don't have those design limitations anymore. So really, those type of parts really get us excited because they're fantastic Velo parts, and it answers the question, why Velo, Mike, right? And a lot of times when we go talk to customers and maybe they're currently active in metal AM and they want to talk about Velo, that's one thing we bring up. Why do you want to print this on a Velo? And by them being able to answer that question, maybe that's we've had challenges in the past printing this part, or nobody's been able to print this part before. That gets us excited. And Tyler has a firsthand experience with a customer. Maybe you can share that, Tyler.
Yeah, sure. I mean, with what we do, I hate not having an answer for someone who comes to us with a challenge. It's very frustrating. And when we have to tell someone no, it sticks with you.
Mm-hmm.
And, there was definitely one situation where we had to tell someone no, who wanted to print a highly functional metal part. But honestly, when I saw the part, I said, there's no way that this can be done. And sure enough, a couple of years later, I see this part printed, not just talked about, but I actually saw it printed. And I instantly recognized it. And we started diving in, like, how did you do this? Who did this? And it turns out it was a Velo part, and someone who had traveled around the world trying to find someone to create this part. And it was a part that, honestly, an entire business was being built upon.
Mm-hmm.
Without this part, there is no business. It was finally done, and it was finally done on a sapphire, which was pretty incredible to see.
Nice. So as a reminder to our audience, this is a live session, and we would love to hear from you. If you have some typical gates or questions that you normally go through when you're evaluating technologies for manufacturing, just go ahead and put them in the chat section, and we'll talk about them. We'll see how they fit into our model here. So Josh, you said a couple things. Kind of 20%, the materials would be 20% of the cost. And I kind of want to break that down. I mean, you put it, the material, and I think that was in your original qualification side. I mean, on the material basis, obviously it has to fit. What are you looking for when you bring in that 20% rule?
Process. So when you've got a part, and they tell us that material cost is a very small part of the overall part cost, and we start to dig in on how this part's actually made, it starts to lend itself more to metal AM, because it's kind of representative of what an AM part is, right? Where when you look at the overall part cost, the material it fits around that 20% mark, and so we can kind of build a 1-to-1 ratio with their current manufacturing method, and then to a Velo printed parts, which kind of goes to show a high value application typically. And that's what really fits the Velo system and the Velo model, is these complex high value parts.
Yeah, I'm getting a picture in my head of like multiple brazing and welding operations, and you've got dozens of components. That's kind of what you're talking about when you talk about the process, all this extra workload.
A lot of that's lead time too, right? So
right.
They may say it takes us 6 months to get one of these parts. And, as we start to calculate, well, what does that time really mean to you? And can you put a dollar value on that time? Then, printing these parts becomes even more attractive.
Yeah, I know, like aviation MRO, we've talked to some folks. You've got hundreds of thousands of dollars of asset that's grounded, and for thousands of dollars worth of part, right? So it's getting that up in the air, getting that profitability running again. It's that lead time is everything. Cool. So I mean, we kind of talked a little bit about cost. Wanted to talk some more about it and kind of break open this, because it is a major question that we've got to deal with. What are you looking for in the cost of their either traditional manufacturer or what their targets are, and how do you break that down and communicate that to AM?
Tyler, you want
me to take that?
Sure.
Well, you mentioned the cost of the material, and I think that's a really simple indicator to look for. I would say most people understand or can easily derive the cost of the raw material that goes into the part. And then they, usually understand the total cost or the final cost of that part. And so there's a ratio there that you can look at. What is the cost of the raw material versus the total cost of the part? And when that swings in one direction, that really starts to justify the case for AM. If almost the entire cost of the part is the cost of the metal. So a perfect example would be if you just took a bar stock and then you cut 2 inches off of it, and that's your part, 100% of the cost. outside the cost of whatever that cut is, a couple cents, you're going to continue just cutting that. But if you're taking a piece of raw stock and you're processing it highly, whether it's on one machine, two machines, it's touching one hand, two hands. Some of these parts that we're looking at are honestly made of assemblies of dozens of parts that are adhered together through welding or other processes that can start to introduce negative lead time effects, negative tolerance effects, and negative quality effects. So that single ratio is a great indicator to begin a discussion or disqualify a discussion.
And we do have a question from the audience here. What are typical finishing applications or post-processing applications that might be used for additive?
This one's easy. Additive metal, you essentially treat the same as metal made any other way. The specs of the Velo machine indicate that for essentially every alloy, you're at 99.9% density. The density of an AM part is something that's come into discussion over the past few years, and whether it's justified or not. But laser sintering and Velo is creating fully dense parts, and they're creating parts that are the true alloy that you're expecting. They're not infiltrated with other materials, and the process is so highly controlled, they're not contaminated by other materials or other molecules like oxygen. So if you can finish a Inconel part one way, traditionally manufactured Inconel part, you can treat it the same way with an additive part.
Okay, makes sense to me. So let's talk a little bit about scaling. Let's say you've got the part, you got the material, the cost structure seems right. And you mentioned before, like some of these systems are used for small scale, but maybe you need a larger volume. What are the options in terms of scalability?
Yeah, with Velo, it scales really well. And the reason for that is the machine-to-machine reliability. You can build a part in California and put it on a Velo machine in Singapore and get the exact same part. Part of that's built into the system, the software, and then creating what they call, a golden build file that you really can source to any Velo printer around the world. And it's able to do that because of the calibration and the machine tool itself. That going into a print, that machine's going to calibrate itself the exact same way it did on that first original print. And so it can give customers that confidence that I can maybe do the development work and scale initially in-house, but then if I need to build hundreds or thousands of parts, I can utilize the CM network that Velo was set up.
And there's kind of scale like what you're mentioning regionally or even globally. We've got printers in Australia and Asia. Now we're going to have a printer in Q1 in Europe, and we've got the US pretty well covered. But both of us got a chance, and Josh, you and I were at the headquarters last week. Both of us got a chance to see the next generation system. What did you think about the XC?
Oh, incredible. I mean, watching 8 lasers dance together on that build plate was something to see. And it's not just even the lasers itself. It's just the speed of the whole process. Watching the recoding, watching everything that's happening in the machine was really incredible, Mike.
Yeah, and just so if you don't know, this is kind of what we're talking about with the XC. With the Sapphire, that's our current printer. We've got dozens of these out in the market. It's a 315 millimeter build chamber. So think of this like a basketball hoop. If you can put your part through a basketball hoop, you can print it on the Sapphire. And obviously that limits, and Tyler, you referenced this before, that limits the parts that we can print. What we've got coming out now in 2022, actually, our plan is to ship the first one by the end of the year. So that's coming soon. So with the Sapphire XC, we got a 600 millimeter build chamber. And Josh, you mentioned we got 8 lasers on this. So you're scaling up production, you're going faster, but you're enabling these larger parts. So that's kind of the XC. And Josh and I both got a sneak peek last week to see this system. And I got to agree with you. This is blazing fast. I understood that 8 lasers versus 2 would be different, but everything about this thing is different. and it is awesome. Tyler, have you had a chance to see the XC working?
I have seen an alpha version of the XC. So as I've been visiting Campbell over the past year a few times, I've seen the development of the system, but I'm definitely looking forward to next year and seeing it in full production and to use Josh's poetic words, the 8 lasers dancing together.
Yeah, it's pretty impressive. Awesome innovation. So we are kind of coming up on time here, and I do want to get your closing thoughts and make sure we kind of capture or cover anything we didn't capture. So where do you think this will all be in let's say 5 years? What does that environment look like? And maybe Josh, we'll start with you.
Sure. I mean, I think we're starting to see this shift right now in the industry where we're moving from kind of a prototyping, low volume production scale for metal additive into a higher volume, higher throughput process. And I think Velo is really leading the charge with that on many different levels, like we've discussed today. So I think, 4 or 5 years from now, Mike, we're going to see factories of Velo systems just, pushing out parts over and over and over again at really a production level that we haven't seen before in metal AM.
Nice. Tyler, closing thoughts from you?
Well, I think that there's been immense pressure building up behind metal AM to go into production over the last 10 years. And there really hasn't been a good outlet for that. And I think it's going to start changing, especially within this next year with the XC release. And so 5 years from now, I think that it's really hard to predict because we're talking with large OEMs that have massive pressure to go into production with AM to the point where today there's not enough machines in the entire country to print the parts that they want to print. And there are not the right machines there to print the parts. And the XC, especially with the quality control component to it, is going to be a huge swing in favor of AM production. And 5 years from now, I think it's going to be unprecedented. Whatever we guess, it's going to be probably double that at least.
Yeah, there's a saying that we used to have is innovations take longer than you want, but they're always bigger than you expect. And so I'm not projecting anything here, but there's definitely maybe something to that where like a single application for metal AM, it's a 2% of the whole metal parts market. And some of these parts can be 2% of the whole parts market. So you're looking at, one application, and that's massive compared to where we are today. So, I agree. I think that's definitely a possibility in the future. So what if somebody wants to get in touch with you? What's the best way to contact Josh and Tyler at GoE?
Yeah, you can reach me at jbrown@goengineer.com. You can also find a lot of information on our website at goengineer.com. Tyler?
I would say just find me on LinkedIn, Tyler Reid, and I'd love to chat with you.
Awesome. Well, thank you. You guys have been awesome. Also, always great to talk to our partners at GoE. And audience, thank you for joining us today. Hopefully, we've given you a bit of a guide or at least a sneak peek where where you can find the answers. So I remember taking all my math tests or physics tests, and it's like you don't have to know all the formulas, but you have to know where to find them. And so that's kind of what we're doing today is give you a guide on where you can go for answers. So make sure you follow GoEngineer. Their YouTube channel is amazing. If you want to learn about SolidWorks or learn about Velo 3D, they've got tons of great content. They're coming out with great content all the time. So follow them on LinkedIn and YouTube, and please follow Velo 3D and stay in touch. We'd love to hear from you. So we'll see y'all on the other side of the new year. Our next show will be in 2022 in January. So stay tuned for that.
Thanks for the time, Mike.